Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Functions make up almost 1/4 of the test questions. Standard 8.f.4. Use functions to model relationships between quantities. Construct a function to model a linear relationship between two quantities. 1 to 2 questions on the test every year.
Hello and welcome. Here is what you need to know before we get to the examples.
What is a linear function?
A linear function is a function whose graph is a straight line.
Y equals mx plus b.
Is a linear function whose graph is a straight line where m is the slope, rate of change, b is the y-intercept where the line crosses the y-axis.
Rate of change and slope.
Given 2 points, any 2 points, x1, y1, x2, y2 on a straight line or in a table representing straight line, then the rate of change is the slope, is y2 minus y1 over x2 minus x1, and that is rise over run. Linear functions have constant rate of change, Example number 1, a convenience store has 20 bottles of water. Each day a supplier delivers the same number of bottles to the store. The store does not sell any bottles of water for 3 days and now has 110 bottles. What is the rate of change? Okay, so obviously it's a constant rate of change. It says here the same number. We started with 20. We ended up with 110 after 3 days. So 110 minus 20 divided by 3, it gives you 3 bottled water every day. Example number 2, a conversion chart between a number of quarts Q and a number of liters L is shown right here. Complete the equation to model L in terms of Q. So we need to find the rate of change. The rate of change again is y2 minus y1 over x2 minus x1. So you can take any 2 points here. Okay, so I did all the differences here, and obviously it's the same. It has to be a constant rate of change. So that's 0.95, and therefore the equation is L equals 0.95 Q. You can check your answer when you get to this point. If you put 1 here, you get 0.95. If you put 2 here, 2 times this gives you 1.90, and so on and so forth. Example number 3, the graph of a linear function passes through the 2 given points on the coordinate plane, 315 and 621. What is the rate of change of the function? Okay, it's the rate of change. We have to call one of these points x1, y1 and the other x2, y2. You can do this like this way, or it doesn't matter which one you call it x1, y1 and which one you call it x2, y2. And the rate of change is y2 minus y1 over x2 minus x1. So 21 minus 15 over 6 minus 3, you get 2. Example number 4, this one is a little bit more complicated, but I think if you just take your time and do step by step, you can get it done. So let's see what happens here. You have some values of 2 linear functions a and b are shown, this one here and this one here. Now function c is a linear function with the given characteristics. They want the y-intercept to be between the 2 y-intercepts of these 2 functions, and the slope they want it to be also between the 2 slopes of this function and this function. So we need to find the y-intercept and the slope of each one of these functions. So function A, slope y2 minus y1 over x2 minus x1, 20 minus 12 over 7 minus 3 is 2. Now to find the y-intercept, use the y-intercept formula. Y is equal to mx plus b. Replace m by 2. So now you need to find b. You can use any one of these points, either this point or this point. So here I used this point. When x is 3, y is 12. So this is 6. 12 minus 6 is 6, so b is equal to 6. So now I have the slope and the y-intercept of the first function. Function b, the same calculation now. Now you have to be careful here. Is 10.5 minus. Many students make this mistake. They don't put the minus here. And the same thing here, 2 minus 1. So you get 4. And the y-intercept formula, now you can again use this the formula and then put the slope is 4. Put 4 here. Now you need to find b. Use one of these two points. I don't like dealing with negative numbers. I can use this, very convenient. So I will put x is 2, y is 10.5. This is 8. 10.5 minus 8 is 2.5. So now, using these conditions here, function c, any linear function whose slope is m between 2 and 4, and the y-intercept between 2.5 and 6. So you have a choice. You can make your choice. Here I chose the function y equals 3x plus 5. So I took 3 here between 2 and 4. And I took 5 here between 2.5 and 6. So the slope is 3. So from passes, this is the y-intercept 5, 3. That means 1, 2, 3. That 3 over 1, that's the slope. And you get the answer. There are infinitely many solutions, okay? Obviously, there are a lot of options that make it easy. Take easy numbers here. Example number 5. Complete the table to create a linear function. See, there's no conditions at all here. You just need to create a linear function. So, in general, a linear function is y equals mx plus b. How I can, make a choice to take a simple one. So I'm going to take b equals 0. Take as an example, for example, b is equal to 0. So when x is 0, I'm going to put 0 here. Now my function is, the one I'm looking for is y equal mx. Now you have a choice here. You can make any choice for the slope. Here I took 2. You can take a 3, 4, 5, any number you want. So if you take m is equal to 2, y is equal to 2x. So now here, when x is 2, you get 4. When x is 5, 2 times 5, 10. And obviously there are infinitely many solutions. Now this question here, I added this question. Now I'm here asking to find the linear functions where the y-intercept is 4 is given now. So I don't have a choice here. So my function should look like this. But now I have the freedom to choose m. So again, here I choose 2. You can choose 3, 4, 5, any number you want. So the function would be y equals 2x plus 4. So now, when x is 2, 2 times 2 is 4, plus 4 is 8. When x is 5, 2 times 5 is 10, plus 4 is 14. Again, an infinite number of solutions.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.